Your hand jerks off the stove before you register the pain. Your foot slams the brake before you consciously see the car pulling out. Your stomach drops before you even know why. What is happening in that gap, the sliver of time where your body already knows something your mind has not caught up to yet? You would assume thought comes first. See danger, think danger, feel fear, react. That is the story most of us tell ourselves about how we work. But it is backwards. Your body is not waiting for your brain's permission. In most emergencies, your body moves first and your conscious mind is left playing catch up, writing the explanation after the fact. Here is what is actually happening inside you. When your eyes or ears pick up a potential threat, that raw sensory information does not go straight to the thinking part of your brain, the part that reasons, weighs evidence, and decides calmly what to do. It gets routed first to a small almond-shaped structure deep in your brain called the amygdala. The neuroscientist Joseph Ledoux, who has spent decades mapping the brain's fear circuitry at New York University, discovered that sensory signals travel along two separate paths at once. One path goes to your cortex, the slow, careful, detail-oriented route that actually figures out what you are looking at. The other path is a shortcut straight to the amygdala, skipping conscious analysis entirely. Ledoux called this shortcut the low road, and it is built for speed, not accuracy. Why would your brain build a system that reacts before it understands? Ask yourself what happens if you wait for full understanding every single time. A shape in the grass could be a shadow, or it could be a snake. If you wait for your cortex to carefully compare the two possibilities, gather more visual data, and reach a confident conclusion, you might already be bitten before you finish thinking. The cost of hesitating on a real threat is so much higher than the cost of flinching at a shadow that evolution built you to flinch first and ask questions later. This is why you jump at a rope in dim light before you register it is not a snake at all. This is why a sudden loud noise makes your whole body tense before you have identified the source. The low road does not care about being right. It cares about being fast enough that a wrong guess still keeps you alive. So think about what this means for the sequence of events inside you. The amygdala receives the raw, blurry signal first. It sends out the alarm, your heart rate spikes, your muscles tense, stress hormones flood your system, all within a fraction of a second. Only afterward does the slower, more accurate path finish its analysis and tell you what you were actually looking at. By the time your conscious mind catches up with an explanation, your body has already been reacting for a beat or two. Have you ever felt your heart pounding before you could explain why, and only a second later realized what had startled you? That gap you just felt is not a glitch. It is the entire system working exactly as designed. Your body panics first because panicking first is what kept your ancestors alive long enough to have you. This raises an interesting question. If your body reacts before your brain understands, how do you ever end up feeling calm and rational at all? The answer involves a second discovery, one about how your brain actually builds the feeling of fear itself, not just the physical reaction to it. The neuroscientist Antonio Damasio, working first at the University of Iowa and later at the University of Southern California, proposed something that reshaped how scientists think about emotion. He argued that your brain does not generate a feeling first and then produce bodily changes as a side effect. Instead, your brain is constantly reading your body, using signals like your racing heart, your tightened stomach, your shallow breathing, as raw information, and then constructing the feeling of fear or anxiety out of those physical signals after the fact. Damasio called these bodily signals somatic markers, and his research suggested that your emotions are, in a very real sense, built from the inside out. This means the tight feeling in your chest is not simply a symptom of fear. In many cases, it is one of the ingredients your brain uses to decide that fear is the correct label for what is happening. Your body sends the raw material. Your brain assembles the meaning. The psychologist and neuroscientist Lisa Feldman Barrett at Northeastern University has taken this idea even further with her research on what she calls the theory of constructed emotion. Her work suggests that your brain does not have a small set of pre-wired emotional reactions waiting to be triggered like separate light switches. Instead, Your brain is constantly predicting what your body needs to do next based on your internal state and your past experience, and it constructs an emotional experience in real time to match that prediction. Here's where it gets genuinely strange. Barrett's research found that people can misread the exact same bodily signal in completely different ways depending on context. A racing heart at a rock concert gets labeled excitement. The exact same racing heart in a dark parking lot gets labeled fear. Your body did not change. Your brain's interpretation of what that racing heart means did. Does this mean your fear is not real? Not at all. It means your fear is built moment by moment out of raw physical data and the story your brain tells about that data, and that construction process happens so fast you never notice it occurring. You only notice the finished product, the feeling itself, arriving as if it were instant and obvious. So the sequence inside you actually looks something like this. A potential threat appears. The low road in your amygdala fires immediately, before you consciously register what you saw. Your body responds physically, heart rate, muscle tension, breath. Your brain then reads those physical signals and constructs the feeling of fear or panic to match them. Finally, your slower conscious mind catches up, looks around, and builds an explanation. This is dangerous. That is why I feel this way, even though the feeling of danger technically arrived before the understanding of what was dangerous did. This explains something you have probably experienced but never had language for. Have you ever felt anxious first and only afterward gone looking for a reason, scanning the room, scanning your thoughts, trying to figure out what you are actually afraid of? That backward search is not confusion. It is your conscious mind doing exactly what it evolved to do, arriving late to a decision your body already made, and trying to write a coherent story to explain a reaction that happened before any story existed. This also explains why some fears feel so hard to talk yourself out of. You can know, intellectually, that the turbulence on the plane is statistically safe. You can know the presentation you are about to give will not actually kill you. But knowing something with your slow, careful cortex does very little to override a reaction that already fired through the fast, ancient shortcut in your amygdala. The two systems are not always on speaking terms, and the older one usually wins the first round. Understanding this does not make the reaction disappear, and it should not try to. That fast circuit exists because it worked, generation after generation, for people who did not have the luxury of thinking things through before acting. But understanding it does change how you relate to the feeling when it shows up. The next time your stomach drops before you know why, or your chest tightens before you can name a single reason, you are not malfunctioning. You are watching a system built over millions of years do exactly what it was built to do, protect you first, and explain itself only once it is safe enough to slow down. So the next time your hand jerks back before the pain even registers, or your foot hits the brake before your eyes finish confirming the danger, remember what is actually happening in that gap. Your brain did not fail to think fast enough. It simply understood long before you did that some moments do not leave room for thinking at all.